Welcome back. The objective of this video is to look at the idea of external rate of return and to go through an example working out the external rate of return. Now, the external rate of return is just another rate of return that we use to work out whether a project is worth taking or not, other than IRR. Now, the reason that we need another rate of return is because there are some problems with the internal rate of return. So let's just quickly go through what are these problems that IRR has. Okay, so the first problem with the IRR is that it assumes all the profit and revenue will be reinvested at IRR. Now, if we work out our IRR to be, say, something like 200%, then it is not reasonable to assume we can invest at a rate of 200%. Okay, now the second problem with IRR is that depending on the complexity of our cash flow, it is very likely that we will have multiple solutions to our equation, and as a result of that, we cannot tell without further work which is the correct IRR, because both IRR will give you the same answer. Okay, now having more than one IRR is meaningless because it doesn't help the situation in any way. Okay, now this is why we use the external rate of return, because the external rate of return bypass all these problems that the internal rate of return has. Okay, so let's have a look at what is the idea behind external rate of return and how we actually calculate it. Okay, so we introduced the idea of an external rate. So an external rate is another interest rate that we use to discount all our inflow and outflow. And this could be maybe a bank rate, so maybe the bank offers 5%. So that is an external rate because it's not within the project, it's not anything to do with the company. Okay, and the first step we do is we discount all the expenses at the external rate back to time zero. Okay, and then the second step we do is all the inflow, the revenue, we compound that at the external rate to the end of the project's life. Okay, once we have done those two, we simply just equate the two equations by compounding the outflow at our external rate of return. Okay, once you have done that, we will be able to work out what is our external return, and if the external rate of return is greater than MAR, then we will accept the project. Otherwise, if the external rate of return is less than MAR, we will reject the project. Okay, this might seem a little bit confusing, but once I've shown you the example, it's relatively simple and straightforward. Okay, so let's go through this example. We have shown that in this cash flow diagram there are two expense in year 0 and at year 1 of $10, and from year 2, 3, 4 and 5 we get a revenue of $5, $10, $15 and $20. Okay, we have been told that the MAR here is 20% and the external rate is 17%. Okay, so let's go through the procedure. First step we need to do is discount all the expense or outflow back to time zero at the external rate. So we know the external rate is 17%. We have two outflows, so we discount each of them back to time zero. So the first one is already at time zero, so we don't need to do anything. The second one we discounted by 1 period to get it back to time zero. So here we worked out the present value to be minus $18.55. Then the next step we do is compound all the inflow to the end of the project. So we want the future value at year 5. Okay, and since we have $5 in year 2, we got to discount that by 3 period, the $10 in year 3 by 2 period, and the $15 in year 4 by 1 period, and we don't need to do any sort of compounding for the $20 in year 5. Okay, if we do that, we work out our future value to be $59.25. Okay, then the next step of what we need to do is equate the inflow and the outflow so they are the same at the future value at year 5. Okay, so we had an expense of $18.55. We need to compound that at the external rate. This is where we want to work out the I dash. Okay, so I dash is the external rate of return, and all we do is we want to compound the outflow by the external rate of return to equal the inflow. And this is our first line of how we will solve for the I dash. Okay, so that's the outflow compounded at the external rate for 5 years, and this is the inflow at the end of 5 years. Okay, and we simply solve for I dash. We're finished. So we divide both sides by the 18.55. We evaluate what this fraction is. We get 3.19. Then we fifth root both sides, and so we get 1 plus I dash to equal 1 plus 1.2614, and we minus 1 from each side, so we get that our I dash is 0.2614, meaning our external rate of return is 26.14%. We know initially we've been told the MAR is 20%, so therefore our external rate of return is greater than MAR, so we will accept the project. Thank you.